That's the design manager. It's primarily a tool to give you an overview of what's in the board, in the design. I will load another board and then it's a bit more comprehensive. Basically, you see in the device view what are the devices, which components do I have in the board, and where are they. So if I click onto one of these, it shows me where is it. So that's something, here it's not a problem, but think of boards. They have more layers, a lot of signals, a lot of components. If you search for something, it's very easy to simply click on this and then you get it. You can also do some operations or some actions on the components selected. For example, if you do a right click, it's not much at the moment. Okay, I can delete it. I can. That's improved, so you have some more options in the next release, and that's an ongoing process. So that you really could use the design manager, select a bunch of objects there, and do something with them. So you can decide on what's on the bottom side, what's on the top side, so I see it in the list, for example. And there we have the signals as well. So that's not much, but you see at the moment we have different signals in the board. If I click on one of these, okay, I can see it, and I see also what belongs to the signal. There's which components are connected, are there traces, are there layers and so on. At the moment there's not very much in it, but it helps also in changing something. The idea is also to say, okay, I have the ground signal and I want to change maybe the width of the traces or something like this. Then I select it here and can very simply change it without using a user language program or without clicking on all the parts of the signal. Okay, I'll explain later. Basically, if you start with the layout design, you have to think, of course, about the board. You see here you get a first board to get a feeling for how much space do I need. In most cases you won't use this frame that's drawn here. And you also see that you have the black area inside, and this other one is it's a bit more grayish, so to say. That's a kind, we call it contour detection. If this is displayed in this way, you can be sure that the contour is closed, so you don't have gaps between. Why do we do this? Because we want to work together with Fusion, or think of if you want to have this board produced. In most cases, this is milled out from the big panel. And if you don't have a closed contour, it makes a problem in the manufacturing process. So that's a kind of detection. I can also switch it off if I don't want to have it. There's an option I can show you later. And the other thing is, what do I want to say? What contour? Yes. But very important is, now you have to think about what am I designing. I should know, of course, what are the components, and I have to think about design rules. How is the board built? I have two layers, then it's not a problem. I have a core like this one, I have copper here, I have copper there. If you know the manufacturing process of a board, then I have a lot of different options how multi-layer board is made. If I have 4 layers, for example, I can have top and bottom and 2 additional inner layers. Then I can at least have 2 ways how to make this board. I can take a core, which would basically be a rigid material, FR4, that's an epoxy glass, what is fiber combination? Yes. And I put, which which is covered with copper on top and bottom, and then yeah, gets etched and so on. If I have 4 layers, I could take 2 of them and press them together. I have an isolation material which is called a prepreg isolation, and take 2 of them. I could also take 1 core, use prepreg, and then put copper on both sides again. And depending on this, how I build the board, I can have different ways of drilling into the board. If I have 2 of them, I can drill there. I can connect this one, the top layer, with the first inner layer. And I take the other one, I can drill from the bottom layer to the second inner layer, and I can put this together, and I can drill through the whole stack again. So I have drills from, if I name the layers 1, 2, 15, 16, or 1, 2, 3, 16, I have drills from 1 to 2, from 16 to 3, and I have 1 through the whole stack from 1 to 16. If I would build it the other way around, I could have drills from 2 to 3, and then from through the whole stack, so there's difference in manufacturing, in options now. And that's something you have to know in the beginning. Of course, there are some standards all the board manufacturers use, but if you think of components like this one, this black square one, that's a BGA, we call it ball drilling rate. If you look onto the board, you don't see connections, no pins, no pads, because all the connections are beneath the case. And this guy has about 250 connections beneath the cylinder. If I have a BGA in this size as the board is, I have about 1500 connections. And if all the connections are used, then it's really critical about layer setup. How is this board built? What are the options for drilling? There it doesn't help to drill from top to bottom, because yeah, I can have 5 connections out of 1500 connected. So I have to think about this. And that's something, okay, the design engineers, my advice is always talk to your board manufacturer, ask what are you doing, what's the default, what are the standard build setups you use, and decide then, take one of them, their design rules. We have some in E, we have some Euro circuits, and I think B electronics and another one. Most of them offer design rule files for E. If they don't, you can also set up this by yourself. They say you have to set up this, that, that. And if you think about a 16-layer board, I need somebody who is good in mathematics. How many options do I have to build? If I have a 4-layer board, I have at least a minimum of 2 different variants. If I have 16 layers, it's much more. For example, Euro circuits, they offer also 16 layers, but they don't offer the whole variety of possibilities. They have 700 different setups for a board, depending on number of layers, depending on minimum clearances, depending on copper thickness. So because the default is 35 micrometers on top and bottom as copper thickness. In the inner layers we have probably 18 micrometers for a default board, but this could be also more. If you have something with high current, you need more copper, and if you have more copper, then you have different design rules, different minimum clearance values, for example, different minimum wire width, for example. So that's really challenging, and so the advice is always talk to your board house and they tell you what you have to do. But you have to know in the beginning, at least you should have a rough idea how many layers do I need. Do I need 2 layers? Here it's okay. The guy initially used 4 layers because he didn't get the design rules correctly for this BGA. He said, I can't do it with 2 layers, it's possible. That's the reason why I have this board in here, because this was something the guy designed this board, sent to the board manufacturer. They said, we can't do this, what are you doing there? And then we together, he contacted me and the board manufacturer, and then we figured out how to set up minimum clearance values, minimum wire widths and so on. And now we have a 2-layer board. And so that's something you have to start think about in the beginning. Because if you have done all the design, and you see I have used the layer setup that works for me, and the board manufacturer says, okay, that's quite nice what you're doing, and maybe you have already a quotation, this board costs 200 euros for example, and you send it to the board manufacturer and they say, hey, what you are doing there is not our standard, we can do it, but you pay 5 or 6 or 7 times the price, or you change your design. And if you change the design, in most cases you start from scratch. And that's something you have to think before. I told you the example of the guys who are working for the automotive industry. This would be impossible because you don't have the time to do this, so you have to think about this before. And that's the reason why we have the design rule dialog. If I go to edit in the menu, but it's not here, and there we have design rules. And that's a dialog. There I have all the settings. I can make it easy. I know I want to have 2 layers or 4 layers, and I say, I know I go to Eurocircuits, for example, and I load their design rule files. That's not the correct path. I need applications. So I did another way. Any of this. So Eagle usually shows you the correct path. But as I said, I have a lot of nonsense here. Okay, I have the design rules. For example, Eurocircuits. I know that's a default setting. I use 4-layer, for example, and I load it, then open, and then get some information. And there we have different tabs, and I have loaded the file, so that's okay at the moment. But of course, you can also do this by yourself and set your rules. But always think it has to be manufactured. Of course, you can design a board with 100 micrometer clearance. That's not a problem, but you have to pay for it. There's a very crazy company anywhere in the UK, I've been some years ago. They design boards, I had never thought that this could be done. They place drillings into the board where I say, this doesn't work. They didn't explain how they do it. They're working for military. I have seen the production facility. Seen is too much. I had 2 or 3 looks because they said, top secret. And it's really crazy what they are doing. But nobody could afford, except maybe the government or maybe the military. Okay, but let's go into the details here. Layers. So that's the layer setup. I have to admit it's not very comprehensive at the moment. We will have some improvements in the next release so that we can easier set up a 6-layer board, for example. Because what I have to do is I have to use the setup line here for designing, for creating the layer stack up. So that's a cut through the board. The green part, that's the core. The gray one, that's pre-preg, that's material, that's isolation material. And then I have the red one, again, copper pressed onto this pre-preg. There are certain thickness values for the board. That's the other way around. Inside we have copper foil, which has 35 micrometers, and there we have 18 micrometers, which is how is it? Let me think. It's quite
1 ounce.
You have, I think you start with 35 micrometer on the board, but you go into the etching process, and so it's okay. I don't know. Doesn't matter. So I have to set this term here. And here again, the asterisk says it's a core, the plus sign indicates it's a prepack. I have layers. I would advise, we have a maximum of 16 layers in EE. But you also, in most cases, you build a symmetric board. So I start 1 is always top and 16 is always bottom. So if you have the freeware, you have to use layer 1 and 16. If you use standard, you should use 1 and 2 and 15 and 16. And if you have more layers, then you say I have 1, 2, 3, 4, and I have 13, 14, 15, 16. So I go 1 down and from down 1 up, so for the number of layers. And yes, basically it's not very critical. If I have
Just here.
should you shut the door? Yeah, please. So if I drill through the whole stack, then I use the parentheses around this. And there's also an option not to drill through the whole stack. I can drill from 16 to 15, for example. I can drill from 16 to 2 or from 1 to 2. That's all possible. You have to pay it. The best is if I do a drilling through the whole stack. So that's a via, and we have so-called blind vias. Blind via means it's not, you can't look through it. It goes from here to anywhere inside. And this is in the production process is much more expensive because you have much more failures in the production, and you have to pay it. It does not pay the board manufacturer for you. You have to pay it, and that's the reason why such more exotic setups are much more expensive than one of the standard ones. It's doable. It's not a problem. It's really crazy if you imagine that you can drill down to 100 micrometers with a quite normal drill tool. That's really crazy. There's a lot of technology behind board manufacturing, and if you have seen the processes, the steps you have until such a board is done, and then you say I have to pay 50 pounds or whatever, 60 euros or 80 euros for such a board, then that's really a reasonable price. And if you then order such a board in China, you pay maybe 10 euros for this, and you get it within a week back, then I wonder how they are doing this. Okay, the problem is here in Europe is that the costs come from the environment. Because all your chemicals, all the copper vests, all the stuff you don't simply throw it away. You have to recycle it, and that makes our processes so expensive. So think about this. If you want to have a 2-layer board, for example, I can stop this. I know I need 1*16. You see, that's my core now. And I want to drill through it. Now I take parentheses here and there, and then you see I have a simple 2-layer board defined. There's much more. Let me check if I can count. Parentheses define drill through the stack. I have this brackets, I think it is, where you say I drill from 1 to layer 2, so I don't drill through the whole stack, but I do it in a certain depth. Then I have to define something like this. I can go on and say, okay, I want to have a 4-layer board. Let's do it this way too, and then I need this, and then I say plus 15, plus 16, so I have 4 layers. Now if you think what I said before, 1 and 2 is a core, for example, I could do, before I press it together, I could do this, and drill this before, here, can do this here as well, so I can make it more and more complicated. I could add some additional layers, and I could also say I want, okay, do the other way around. Say 1 plus 2 star 15 plus 16. Oh, no, that's wrong. That's 16. Now I want, this is a pre-break that's relatively small. You see about 2.36 millimeters. I can do a blind view. Then I would define this by 15. Make, where are the parentheses? No, that's wrong. No, that's also wrong. There it is. Then go there, and then need this one now. Yeah, that's wrong. Here, no. Yes. So I could define something like this and say, okay, I'm going from here to there. But, okay. You see, we have a lot of options. Just to show. I have a very good chapter in the manual about setting up such layer stacks, and I have we will have some improvements soon with the next version where I say, okay, I can do it still as it is here, but I have an additional option. I say I want to have 6 layers, drills from here to there. I simply need to click into the drawing, and then it will automatically create this term here to define it. Okay. So let me, okay, exotic, like this one. Okay, so what else? We have clearance values. Here you see.
Most of what we're doing now is it's a 10.
You see here we have, that's the industry standard 150 micrometers is no problem to produce. The clearance between wire and wire, between 2 traces, between a pad or an SMD and a wire, so we have different values here. Usually it's always the same. And we also have some minimum clearances between objects that belong to the same signal. That's set to 0. Sometimes it makes sense to have a minimum clearance. So the designer check tells you, hey, these 2 SMD pads are too close together. This, the background is if you do soldering of such components, you don't want to have that your solder material comes from here to there and then you get one big bulb. You want to have some space between. Usually there's some solder stop over this trace so you don't get the connection there directly. So it's a secure way to solder this stuff. So that's okay. That all goes too far now, but it's really not so easy. And I'm surprised how many boards work if you see how they're done. Okay. Then we have some distance. Yeah, we call it distance between the dimension of the board and the copper. Think of something, you build the board into a metal case, so you don't want to have short circuits. So that's the reason for these values. Then we have minimum sizes. Again, trace width, the minimum drill for the vias we have. Then we could have micro vias. That's something that's a very small via from the outer layer into the first inner layer, or one layer deep. Yes, I can set this. That's a very high value, so this means no micro vias to find. Then we have something about annular rings. So that's something. I have through-hole components. I have a drilling and a copper ring around this, and there the size of this is calculated. Take the values you get from the board manufacturer and everything is okay. So no need to change normally. Sometimes you have to, but leave it as it is. Then I can set some basic design rules. SMDs, surface mount devices, normally they have a rectangular form. in some soldering processes, people like to have rounded corners, so I could set this as a general rule, global rule in the board. And I can also distinguish between the pad shapes in for the through oil components. Some people like to have maybe a round on top, square on bottom, something like this. So all the options are here. You can have long pads. This means it's a long pad. It could be extended to I think 2 to 1, twice as long as the width is, or no, 4 times as long as the width is. Sometimes this makes sense, and you can also have the hole not centered in this, but this way. So a lot of stuff. That's not so critical. I think people use it, but it's not very often. Yeah, no, I don't say it's used as well, but I think take it as it is. The first approach is it's okay. It's fair.
Teardrop function.
Teardrop function, not yet. We have a user language program that helps in creating teardrops. You run it in the board and it sets teardrops where it can. But there will come something soon about teardrops. And okay, supply, that's something about polygons and the thermal isolation. If you think you have a drilling like this, and you put copper, full copper around this, and you want to solder this, then all the warmth gets into the copper area, and to avoid this loss of heat or whatever, we draw some small connection wires so that the soldering is good, and that's something you can set here. And then we have some mask data. That's something, the board, for example, this one is green, so all the copper, you only see this golden contacts, and all the other stuff is covered with solder stop, lacquer. And here you can decide how big is the solder stop mask, all these pads, all the assemblies. And the same is for surface mount devices. There we have a solder paste. We call it cream frame. The correct term is, I think it's solder paste. That's a material you bring onto the contact area of the surface mount device. Then you put it onto this solder paste. And then you put it into the oven, and then it will be soldered. So that's something you have also to think of. In most cases, as Eurocircuit does, they say we make it the same size, or we want to have the data the same size as the SMD pad is, and we decide about the final size of this mask. But you could also define this by yourself. Think of very big SMDs for heat. I don't know what's the name. If you use it for kind of heat sink or something like this, then you can't cover the whole SMD pad with solder mask. That's solder cream. You have to have smaller part of this cover. So that's all. You can do this manually, but these are things. That's something the design engineer has to decide on, or he has to look into the data sheets of the manufacturers, because in most cases they tell you makes sense to have this or that area count with solder paste. Okay, then we have a number of design rule check options, check font, angle, restriction, and so on, so I can switch on and off some of these checks. Interesting, you asked for the differential pairs. Interesting is the gap factor. So this decides about the way how the meander looks like. Is it close together, or is it more wide? So that's can be set here. Minimum value is 1. It could be more. This maximum length difference in differential pairs, that's only for the indicator. If you have two wires on the mouse, you see the length displayed. And there is one is green, that's usually the correct size, and the one is red. And they can define a tolerance when we consider it as the same length. 10 millimeters doesn't make sense yet. That's I don't know where this value comes from, but okay. Okay, so basically here you have to decide about design rules in the beginning. If you have done this, say okay, or simply load one of the design rule files from board manufacturer, then you are on the good side. Okay, then the next thing is about the board contour. You get always this, if you don't want to have it, you can simply go there, do a group, use the delete command here, and do a control right click, and it's done. It's gone. Here, now you can draw it by yourself. You could import it from Fusion if somebody has drawn something in Fusion and say, okay, I put it from Fusion, or I could import an XF file or something like this if somebody has this, or you draw it. I will make easy. Then we have, I use the wire command, or the line command, that's the correct one. And then I have to decide about the correct layer. The board contour is always drawn in layer dimension. It should be dimension. Okay, I simply start here again at the origin. The width is not so critical. We have the 6 mil. I'll tell you a bit more about sizes and so on. And now I could, you have the coordinates here. Okay, that's the mil. I could change with the right click. I could change the wire band, and then it define something. You know, and if you close it again, then you see that's what you want to do. Very simple. This could be complicated as you want to have it. I could use coordinates to type in to make the contour. Also, that's possible. In most cases, I think I don't know. You would get something from the mechanical guy. If you don't have it, well, yeah, keep it as simple as possible. Or if you have some DXF files, also import. And this could be done through file import. You see there we have DXF. There is a dialog. That's a user language program which is working here. And now I have to search for a DXF file. Check maybe I find one. Not here. Yeah, whatever this is.
Yeah.
I'll try this one. Just try. Okay. Then I can select the layer because it's a universal tool. It's not only for importing a contour. This could also be a logo or something like this. So I select the layer, 20. I have, in the background I already have a contour, but it doesn't matter at all. I simply click OK. Here comes a dialog. These are the commands Eagle now executes. You see? And then say run. And here we are. Okay, that's my board now. It's the wrong size. I didn't take care on imperial or metric units, but that's actually a real board, and all the components were located here in this ring. So you see, I could use this as well. If I would delete this one here, then you will see that also the board detection will work. Yeah, here that's the board. Then I can place the components. Okay, so let's keep things simple. I can undo all that stuff. By the way, I have also an undo list. So here we see what happened recently. I think let's go back to there. Okay, doesn't matter. So let me continue. And close. No, it's the wrong. No. Why is it? It has changed by the user language program. So this also changes something. Is it 8 minutes? 6 minutes? 8, 6. Yeah. Okay, so I go down. Doesn't matter.
So how did you get to the list of undo? Right, click on the undo.
No, it's in the menu. It's edit. And there's undo videos.
Yeah.
You also could put it onto a key with the command undo list.
Okay.
Then you could get this one.
Yeah.
Okay. Some words about layers and settings. You have seen we have some layers in the schematic where you draw the symbols, where you draw the nets, where you draw your bus and so on. And that's the same in the layout editor, but there you have much more options, of course. And if you go into the display menu again, this one, you see a number of layers there. You don't have to know all the layers. The first 16 would be for the signals. Copper layer 1 until up to 16. We used in our setup, we used 4 layers. That's the reason why we have 1, 2, 15, 16 here. 1 and 16 is visible. Pads and vias. These are functional layers where we draw the pad and the via. Unrooted, this is where these signals are drawn. Dimension, that's where we draw our board contour. Then we have T and bottom place, T and B place. That's basically the silk screen. That's what is printed on the board on the top or bottom layer. And additionally, we have names and values layers for the top and for the bottom side, of course. Because I can have components on top or I can have components on the bottom side. So I need different layers for this. And the same for the value texts. Then we have this T and B stop, top stop or bottom stop for the solder stop mask. So that's a layer which is automatically generated, but you have to have it because you need it for the board manufacturing. If you switch it on, you will see that you get some symbols here in this layer which indicates that's the area where I can reach the copper line and so on. Not covered with solder stop. Same we have for SMDs with the cream frame. Again, that's where I have my solder paste. So it's quite. Then we have top and bottom finish. There's nothing inside by default, but you could, if you have, for example, such a board. These are, if you have some connectors on the board, for example, think of what's called a card in a main board, for example, PCI card or something like this. You want to mount it and unmount it, you have a connector. And in some cases you want to have these contacts plated with mostly with gold, because that's very resistant and has a good mix with contacts. So you need an additional layer where you draw the mask for the gold plating, for example. So that's the finish layers or whatever it is. And then we have glue layers, nothing inside by default, but if you think of such components like this one, they're also in bigger sizes. If you would simply mount it and put it onto your solder paste and you turn the board around, it will drop off. So sometimes it makes sense to glue this before you put it into the soldering. And you have to solder on both sides, for example, but because you have components on both sides, then the components must be fixed on the board. Otherwise, you turn it around, it drops off, so it doesn't make sense. Then you have 2 or in most cases 3 points where you have glue, then you put it on the board, it's glued on the board, and then you can go on with the process. So there's a lot of stuff to think of. Then we have 2 layers test Let's test whatever you want. Then we have keep out layers. That's the same. You see it here. If we move these two components, and I put it in this way, so then you're good. If these lines are drawn in keep out layer, if this would one line would cover the other, or they would cross or something like this, you would complain and say you didn't respect the keep out layer. Because some components, you need some space between them. Otherwise you can't mount them, or maybe soldering doesn't work. So they don't have to be too close together. That's what we use to keep out layers. Then we have restrict layers. That's the next one. I can define areas where I do not want to have copper. So that's something, whatever. If you put copper in this area, you would complain. So you see a lot of layers. Then we have drills and holes. Yeah, drills and holes, that's basically where we have the drills, the drillings. Drills are the, I don't know the difference between a hole and a drill in the English language, but a drill is basically something, it's plated through. We use it for through-hole components. A hole is not plated through, it's a kind of mounting hole, so I have no copper connection from top to bottom. I would this consider a mounting hole, but this one is plated, so there's a mixture. It's a matter of manufacture. If I have copper around, it will be plated. If I don't have copper around, I can't plate it, right? How should this work? So yeah, you see a lot of different layers. Then the important one, it's milling. So if I want to have milling contours, some openings, cutouts in the board, I would draw this in the milling layer. So the board manufacturer knows, okay, I have to mill this out this area. That's something that also works now with the board contour detection. If I draw something in the milling layer, you will see that Eagle recognizes this. And we also take care of this with the CAD processor.
Good question, because on the DXF import, where I can see that's really good to create some complicated outlines, if you've got an internal aperture which is routed out, it would be better to use it on the milling layer instead.
I would use it in the milling layer. Because
that would give some indication to the manufacturer about the sequence of milling then. You would want to mill the external perimeter and then an internal aperture.
I think that's something the board manufacturer has to decide in this process what to do first. Usually they know what's inside the board should be milled first. Of course the board contour. The boards in most cases they are milled. If it's a more complicated contour.
Yeah.
Sometimes you can scratch them or something like this.
Yeah.
Or maybe use a saw and cut them out or something like this. No, but usually it's milled. But they have to decide what's inside, what's outside. And that's I think the reason. So if I just let me finish this and then we talk about this. Then we have a layer measures. You can have some dimensions, measure lines or something like this. Then you can use this layer. Document, reference, whatever you want to put in there. And we have T and P doco. That's what you see here. These rectangles on the solder area, that's something, of course, I do not want to have on the board because I can't solder if there's something printed before. This is a special layer. It's drawn in 51 with T doco layer for documentation prints. If I want to have a printout on paper, on a PDF, then sometimes you have to document which components are on the board. And if I switch off top and I don't have these rectangles, I wouldn't see anything. I couldn't recognize what's the component look like. And so I draw something similar as this assembly pad. So I switch on T-Doco, all other layers off, and then I see that's a QFP or that's a resistor or something like this. So that's a nice documentation print. Okay, so a lot of layers. That's also if you need what's for what I will give you a reference to the manual. There's a list of the layers, what can you do with it, what's named for. And of course you can define your own layers, that's also possible. A lot of options there. About the milling. If I decide I need a contour milled out inside, then I use again the line command. Now we know we have to use milling, this one, and then I start drawing something like this. I close the contour, I stop the command, and you see now it's not very recognizable, but the border area is black and the other stuff is gray. So here you see
Yeah,
it's detected as milling, and the board manufacturer will do this first, and then of course the last step is to mill it out of the pattern. And the new CAD processor also recognizes this and creates data automatically if you have some stuff in the milling. Okay, so a lot of words for one. Next step is, of course, you have to think about the grid of your components. That's the next important thing, because let me display the grid. We have a default grid 50 mil or 1.27 millimeters, which perfectly fits to a lot of through-hole components and to a number of SMD surface mount devices. Here you see, yeah, this fits perfectly. This one, it's not so good because, well, the SMD pads are not on the grid lines. And if you route manually, you draw your grid lines, no, you draw your traces on the grid lines. So if I want to do a connection from here to there, just let me show you. I go out here. It's only a small one. I go there, I go there. But then I have to go. No, there's no connection. Sorry. Let's take this one. That's not a good example. Yeah, what happens? I have to jump here, and so it's not probably probably adjusted in the middle of the SMD. If you have problems with space, you have 150 micrometers between the SMD pads. Every micrometer counts, and something like this is a problem. So you should align your components not the components, the SMD pads or the pads on the grid, so that I can really go out of the center of the SMD pads, so that I can keep my distances to the SMD pads next to this one. So I have to think about grid. What I would do in this case, I take half the grid. I can keep the mills and say I want to have 25. Looks much better. Now I can simply go from here. That's not connected. This is problem. Okay, I can undo this one. Now I go straight up here. You see, now I have optimal conditions for connecting. So that's something you have to think about. And if that's something, if you have a different number of components with different pitch or with different grid settings, take the smallest one, adjust this one because that's the most critical with the smallest pads, and then you can always jump into a wider grid, bigger grid one too. But that's something you have to do in the beginning. And then we start to move the components with the move command. Click on one of the components. Let me undo. We can do this later, and then move it anywhere onto my board. So that's, I can rotate this. I can also have an arbitrary angle. Let's say 30 degrees. Enter. No. It's already done, so I don't have to hit enter anymore. Now I can put it here, put this one there, and that's very tedious. Now I have some routes drawn before. I use the rip up command and say, for example, rip up all signals. click on it, yes, and now I'm back in this unrouted state. So, then it goes on, of course, you could have components on both sides. This, and I always look, no, that's not true, but components are always defined in a way so that they are on the top side. You're looking from above, from top onto the top side. I could flip it or mirror it to the bottom side. So what I could do is right click and do a mirror. Now you see it's on the bottom side. The SMB is blue, the text is mirrored as well, so I recognize, okay, it's on the bottom side. If I have it on the mouse, on the move, and I want to mirror it before placement, I simply click the middle mouse button and it's mirrored and I can place it. So, yeah, that's the first step in basic components. And it should be done in a way so that, okay, this board is not very useful, but I show you another. Right, save, yes. So you see a number of airwires, signal lines, and if you would place, for example, this component, I move it to next, you see that's following the mouse. If I would rotate it by 180 degrees and would place it this way, you already see that's not very good to place it because I have a lot of crossings. And all these crossings I have to take care of when I want to make my connections. So you can a little bit estimate, is it a good or a bad position? Should I rotate it or not? Something like this. And you should always keep it as simple as possible. If you can do everything on one layer, keep it on one layer. It's cheaper in costs, it's easier in design and so on. Okay. Arrangement of components. So here is something I can, as I have done before, of course I can use the move command, click on this one and move it anywhere. You have seen that the components are randomly placed in the beginning left of the board. And if I have a lot of components, it's tedious to go zoom out, choose a component, click on it, go back into the board, place it. So even if I do not see a component, just let me show you, I have the move command active, and I want to use or move R1, the resistor number 1, I type R1, enter. What happens? The resistor or the component jumps to my mouse. So that's if you know your schematic and your board, then most people work this way, because I know I have an IC1, I have a diode 1, I have this and that. I don't have to move around, go back there and change the zoom factor and go forward back. So it's something that's a combination of clicking and typing the command line and something like this that helps in creating a board, that makes it more efficient. And then, of course, you can start as soon as you have 2-3 components placed, you can start doing the layout. Or I place it first and start then doing the layout. And that's something I would show you here. I would like to show you. First I want to delete these polygons, just to make it a bit better visible. Okay, let's say that's what we have done. You see that's the old eagle logo. Now I start with the root command, and here again think about the grid. I have here 1/4 millimeter, I don't know, I switch on the grid display and then I check the positioning of my components, and this looks, yeah, not very well known. I think you have seen it's working, but if it's critical, we should think of moving this component into the grid. Here we have to decide what the grid is. I think it is, I don't know, but that's the wrong grid. How to find out? Look in the data sheet, look in the library, maybe it's mentioned, or I can use a kind of measurement tool. I don't have a real simple way to do it, but what I do is I switch to a finer grid. I simply say 0.001, that's fine enough. Then I use the mark command. That's something to set a relative origin. I go there, zoom in. Okay, I have the notation switched on, doesn't matter. I click here, then I go down there, and you see the coordinates. No, it's the wrong place, I have to go there. Let's go there. Approximately. And you see in my relative coordinates here, it's okay, it's 0.65 millimeters pitched. That's what we have there. And so I can think about using this 0.65 millimeters to get out all of the connections from this component. So yeah, that's really craftsmanship. I don't know. It's something. Yeah, that's the challenge of layout. But I think that's just to show you what you have to think of. And
So just while you're talking about coordinates,
yeah.
I hadn't actually seen that relative coordinate thing before.
As soon as I place this
Yeah.
mark anywhere, I get additional information.
Yeah.
Later on, that's relative to this
Yes,
origin,
yeah.
and I have also polar coordinates. So if I want to have something arranged in a radial area, I can use distance plus angle for whatever.
So if I wanted to move something by typing in the coordinates,
Yes.
are
that's
they
it.
always absolute or they're sometimes
It
relative?
depends what you type in. If you type the coordinates like this, you open the parenthesis x coordinate, y coordinate,
Yeah, yeah.
then it's absolute.
Yeah.
If you have the r inside,
Okay.
then it's relative. If you have the p inside, then it's polar coordinates.
Not really helped.
Polar referring to this.
Yeah. Yeah.
this
No, I can see
relative
that's very
origin.
useful.
Yeah.
Yeah.
So I could type in parenthesis open p o r 0 space 0.65 whatever.
So if I want to move something a specific amount,
Yes.
I can just drop the relative coordinate at the starting point and
Yes.
then
Yes.
just say move R and then
Correct.
it just
Yes,
does
correct.
it. Yeah,
Yes.
yeah.
Yeah, that's
Which may be much easier
Yeah.
than
Yeah.
trying
For
to
sure.
position it
Yeah.
with the mouse.
So you don't have to calculate those.
Yeah. Okay. no,
Yeah, that's also I'm using this for the measurement stuff. And here you see it's about 6.5. Okay, if I would okay. And now let's see what happens if I use the 0.65 millimeter grid. You see, it's not on grid. What I could do is, it's a matter of the library design, I can try to move it in a way so that it fits onto the grid. Why doesn't it fit? Okay, that's the design problem. That's I could change the grid finer, set the multiple and place it in a way so that I can see it. Okay, doesn't matter. So now we start the routing. That's one of the things I want to show. I would like to use a bit of a finer grid because you see the 6.5 is too much. Let's have, I go back to the 25 minutes. That's not so bad. Or even finer. You can also use a finer grid, that doesn't matter. Let's have 5 minutes, for example. So we have all the options here. Don't use it too fine. Eagle calculates with a resolution of 6.125 nanometers. You could use this grid, but you don't get straight connections. Okay, doesn't matter. Root command. Yeah, click on it. There are different options. You see, we have a lot of options here in the parameter toolbar. We have an ignore obstacles, we have a walk around obstacles. The ignore obstacles is something you have all the freedom to draw connections. If I would use this mode, click on it, I have to decide about the width of my trace. You know, we have 150 micrometers, which is pretty good, 6 mm, and it fits nearly. But if you look now and compare the size of the pad and the width of the trace, this doesn't fit together. The trace is too small. Of course you can do this, it's manufacturable, but the bigger the better. If we have enough space to use bigger traces, then we use it, because it's better stability for the board, better connection to the components, better connections to vias, and maybe somebody has to repair such a board because one of the components is no longer working. You want to change it, put it on the board, and then each mill you have is better than such small connections. So I would suggest to, let's say, use 12 mils. How does it look like? Could be more. Let's take 20 mils gas, for example. Doesn't matter. So, okay, now yeah, okay, could work. So you see, I can go on and work, and it shows me where I have to go to. The signal line goes to the target. I could go down here and go inside, and you see the 20 mils. It's just okay for the small one here. So I can go on, click here. Okay, why do you take the small? Okay, if this happens, then there is the setting. I have to change it. This is how to set groupings and drill. So it always takes the values from the design box. Because we say the minimum value is this. If I switch it off, then it takes the one I have there. I have to change it once again. Click now. What's happening now? I can't click onto my.
You've got a caret in your command thing.
Yeah, that's it. That's it. So I have to change it again. Okay, I will add layouter. Oh, that's too much. Let's keep the 20. Go down anywhere. Okay, so take another one. Let's start here, and that's what I can do directly. And in this mode, that's what I wanted to show you. You can do all the nonsense you can imagine. So what you see is, if I switch off the grid, then you can see it better, that the design check immediately shows you some error polygons. It's the live DOC we have there. You can also switch it off. But that's an indication that there's something wrong. If you're not very good in routing or routing, then you could use the walk around obstacle mode. Take this one, that's the default setting. And if I do this here, then nothing can happen, because Eagle would avoid all the obstacles. Doesn't make sense to do it this way, but you see you're on the safe side.
Sorry, before you go on, just to clarify, if you start a route and you decide you then want to make it 30 thou, and you then complete that track, the next time you start to put a track down, if you unchecked that thing you did in settings, it'll then remember that. Is that right?
Yeah. So if I now have 20 mils, now I change it. I have to look that. Change it to 16 mils. Go on. okay, go there,
Yeah,
and now I go on and do a new connection,
yeah,
then it will take the
Ah.
16 minutes.
fabulous.
Yes.
I've been looking at that for many years.
Good. Yeah.
Can you just set it up there so I can write that down?
It's in options.
It's
There
options
are all
set.
the settings for the layout editor are all inside the settings menu, including
Yeah, yeah.
the colors, the new highlighting,
Yes,
and so
yeah, I've
on.
seen that,
There is
yeah.
MISC, and there we have auto set root and width, and rel.
But if you're using auto router, you need to have that checked.
No,
You
the
don't.
auto router takes all his care on the minimum list, on the minimum values. He always takes those. If you would like to have the auto router using 20 mils,
Yeah.
then you have to put it into the design rules.
Okay.
And you see some other options: display pad names, display signal names, pads and traces, and so on. Display your lengths. So that's the reason why I said it's quite nice to name signals or LEDs in the schematic, because here you see the names again. So it makes it much easier to see what's happening. And if I want to change the layer, so I started here in the top layer. You see we have top. If I press the middle mouse button, I get, okay, we have 4 layers there. I get the selection menu. I have to select where do I want to go to. If I have 2 layers, it automatically, of course, goes into layer 16. I select 16 here. Okay, what happens? Nothing. Why not? I didn't click correctly. 16. Okay. No.
Because it's a through-hole pad on the
Dann dann
level you go from.
Gut schon there. Yep. Double click. Oh. Ah, yes. I know. Look into the design rules. What did we define there? Yeah, up to 16. That's correct. Ah, I didn't see it. Okay. Yes, you see, there are vias here, but they're so small.
Yeah.
So because we have a width of 60 millimeters and the drill is 8 mils, that's nonsense. Okay, that's something because I have unchecked now this option, and also it's also valid for the drills. But whenever I define 8 mils, so I take another value, so it makes more sense. What is 30 mils? I don't know. Okay. So again, root command. I would like to change the layer. Where are we now? I'm on top, I want to go on the bottom. Now I see the mirror on the mouse. I can also, of course it takes care on the minimum distances, place it anywhere, and then I go on in the other layer, go back, and then I do my connection where it goes to. So, on the bottom I have to change the top again, it doesn't make sense. But just to show you, so that's basically work I have to do with routing. Doesn't make sense what I'm doing, but just to show you.
Can you not do that with the space bar?
To change the layer,
Yeah.
yes, that's
Yeah.
possible. So I can click onto this one. I start in the top layer,
Yeah.
and now I can hit the space bar. I get the layer,
Yeah.
and then I'm in the next layer.
Sure. Yeah.
I can go on. I only can click from one layer to the
Yes,
next.
but if you're just doing a two-sided board,
Yes.
the space bars.
Yeah, but
Yeah.
I think that it should also work the other way. Let's go back. 1, 2, 3, 4. Run again. Space bar 1, 2, 3. I have to hit it 3 times.
Yeah.
That went in the
Yeah,
bottom.
yeah.
So I can go through the next.
Yeah.
Yes. So yeah, that's the expert here. Okay, that's one way to do it. Then we have another way which is much more convenient. Now, you see, we have to walk around obstacle mode, so it walks around the obstacles. And you can also use the push obstacle mode. I don't know if it works in this situation at the moment. I would like to go there. And either moves away, press it. Of course, I don't get further here because yeah, it doesn't doesn't make sense, but okay, you see, we can also push them away. That's quite convenient if you have 3, 4, 5 traces running through the board and you need space for the 6th one. Then you can push it, and if it's possible, you try to push this away. These are features they have been implemented with the shortest time from our dev people, and that's something our customers are asking for 500,000 years. And since all this, that was one of the things, one of the guys who did this, he actually lives anywhere in the Rocky Mountains, took a plane to, I think he flew to San Francisco, and when he dropped off the plane, the first thing he did was sending a message in Slack. It was a short video. Look, that's the new push obstacle mode. And that's something, yeah. I told you, we have people there are really crazy because they developed this for several other systems, and that's something I would have never expected from the old team. Okay, so, and another thing is, here you always have to do it manually. You have to start, you have to decide about the way, and you have to find your endpoint. And then we have something that's called quick route. So these are these options here. Quick route, AirWire, and whole signal, a bunch of signals, AirWires. And if I take this one, and I click here, Eagle takes a second, and you simply click here and you get one connection done after the other. So this quick route does not take care on the current bit setting. So it decides on its own. There's a kind of artificial intelligence. So you see, I get click, click, click. That's the student mode. Simply.
Yeah, as soon as the student realises that exists.
If it's good or not, that's something you have to decide. But basically, it follows the design rules, and that's it. So, quick. It's a quick autorouter. It's a manual autorouter. Autorouter. Sorry. We have different. You can say click this route one AirWire, route the whole signal. This also can be done. So if you have a more complex signal, then it will go through that. That's also one. Think of ground signal, but there is a limitation at the moment. It's not possible to have more than 16 or 20 air wires in the signal to have it done completely. But it helps in quick, and you can also say, I want to have several signals mounted. Let me undo a bit of this stuff. I go there, use this one. I have selected this multiple air wires, and how do I select it? I simply click here, have a line. No. Why doesn't it work? Oh yeah, what am I doing wrong? It should be highlighted and should rooted. Why doesn't it? No.
It says you have to enter key.
Yeah, sure, but it should be highlighted, and that's what it isn't doing.
Is it because you're on the bottom layer?
Yes, correct. Thank you. You see, okay, now it works. Thank you very much. Okay, here I select the number of signals, SMB pads, and then I think I have to hit the enter key, and it's processing these signals. So I can have, if you think of a bus structure or something like this, it's quite nice to select them. So that's something that's really, really great. And then there's another word, it's smooth signal, just to show you, the guys who are working with this. If I use this, we try to optimize the way of the signal. So if I click here, nothing happens. Okay, but sometimes you get rid of some bands and something like this. Maybe
Cleans it up.
it cleans it up, yes, correct, here. Yeah, you see,
Yeah.
clean up are there. Okay, this can't be done. It's a bit limited. It can't do everything, but you can clean up the band afterwards. So for your students, quick route, clean up. Yeah, it helps in saving time. And sometimes if you have a prototype or something like this,
Yeah.
before you start the outbound, I mean you have to make a break on this. Or, before you start the outbound, you configure it. So it's much quicker to simply click here and select my signals bunch and it's done. That's really, really nice. Yeah, so that's basically the stuff the layouts are struggling with, because that's the challenge now, to have connections done that really work. If I look at this, it's not very nice. It might work, but you have to think about how to place the components, how is the way of my signal, where do I put it. I have to take care on different signals. I have high current, high frequency, some impedance stuff. I can't simply mix this all together. I have to try to sort it out what's where. It doesn't make sense to have 220 volts through your oscillator or something like this. This doesn't. So that's really the challenge in deciding. Eagle can't help you in this way because you have to decide what to do. Eagle is the tool where you can realize your ideas you have. So let's have a break. Yes, you see, it's quite complicated, and that's the reason why I say we have very special, peculiar special. I think it has a negative touch. We have really different customers.
Very polite.
They have really some expectations, and they want it exactly as they expect. And if you do some nonsense calculations, you get immediately complaints from here and there. Like, hey, what's this for? Why should I use this? Doesn't make sense.
Don't use it.
Sorry? You seem to have to notice
Yeah, I'll just make sure. I'll keep my eye open for you.
What you also can do is you can flip the board. But I think that's
Not dangerous.
no, I also thought it's more critical, but sometimes it really helps to flip the board.
Yeah, no, I've not noticed that.
Yes, that's one of these.
You just need to be a bit careful.
Yes, one of the other things, yeah. And that's also one of the things. This single layer mode. So you see only now the top layer, or if we go to bottom,
Okay.
you only see the bottom layer colored and all the other stuff is grey.
I've looked at it, I've never used it, I've looked at it and instantly.
Sometimes it helps if
Yeah,
you
yeah.
if you have more layers, for example, or
Yeah.
if it blends properly. You can have. Yeah, that's one of the things. And what else is interesting? I don't know if you like it, but I'll show it to you. Let me do this down here again. Okay, switch this on. Flip it back. depending on the, no, it's also not so good. That's lost. Depending on the layer selection box here, if I now go to top, changes the display in the
Yeah.
in the editor. So the layer which is selected there is visible on
Yeah, no, I've seen that, yeah,
You've
yes.
seen this?
Yeah.
Does this make sense? What do you think? So I can decide what to see a bit,
Yes.
a bit at least.
No, I've seen that.